Hello, I'd like to welcome you to the PASS Business Analytics virtual chapter meeting. This is our first meeting of the year. Want to ask you to look at the resources that we have on PASS, on the PASS site that we have. Make sure that at the end of every meeting, if you've missed a meeting, that you go to our archive section and look for our recordings and slides out there. We typically meet on Thursdays, 1 or 2 times per month, and we'll be having lots of different topics coming up.
Effort for Cisco Consulting Services. This is a relatively new capability that we are building within Cisco. In fact, we have a very small team of professionals who are incubating this competency within Cisco, so we are still in early days. And I've been with Cisco for about 8 years, predominantly in a professional services, consulting, business development role. Prior to Cisco, I spent many years at Accenture. I was a partner in the strategy practice, and before that at other consulting companies. I've been in the workforce now for almost 27 years. I started my career many years ago as a software engineer, and before moving into management consulting. So what I wanted to talk about was obviously big data and analytics, and give mostly a perspective from Cisco's point of view. I'll begin by first describing our strategy, which is all around the Internet of Everything, IoE, and how that relates to big data and analytics. And it's a very huge opportunity, not just for Cisco, but for all companies. We've done some really good economic analysis within Cisco to size the opportunity, and I'll talk a little bit about that. Then I'll speak a little bit about our relevancy and approach to data analytics, and then I'll close the discussion with with just offering a perspective on how we are approaching data science and analytics internally within Cisco. Okay, and just as Melissa said, if you have any questions, please pop them into the questions panel on the right, and I'll be delighted to answer them as and when they come up. So, and I'm just going to let this slide build. Cisco, as you all know, has been at the forefront of innovations in networking and the Internet for more than 25 years. And in our opinion, the Internet continues to evolve, and we see this evolution occurring in 4 phases. So if you look to the left, in the mid-1990s, it was all about connectivity and providing digital access to information, whether it was through browsers or search engines or email, etc. Then as we moved into 2000, we moved into the phase of the networked economy, where there was a whole push to e-commerce and digitizing the supply chain, XML, EDI, and so on and so forth, and a lot of emphasis on a collaboration between partners across, across the value chain, across the supply chain. So it was all about digitizing business processes. Then starting around 2003, 2004 until even now, the Internet was all about immersive experiences, bringing social and mobile into the picture, video. And this market transition or this revolution is still happening. There are quite a few innovations around collaboration and video and enterprise social networking and so on. And these collectively we call them immersive experiences. So whether it's consumers or people, professionals or knowledge workers, we can now interact, communicate, collaborate, using a variety of media, rich media at our disposal. And this is having a huge impact on productivity and innovation, so on and so forth. And, in fact, starting around 2011, 2012, we are entering into the fourth phase of the evolution of the internet, which is all about, what we call the Internet of Everything, which is mostly about, going above and beyond the Internet of Things. And I'll describe the distinction between the Internet of Things and the Internet of Everything. And it's all about, connecting people, process, data, and things, essentially, digitizing the world. So what's leading to all of this? We've been talking about the Internet of Things for many years. One of the key, forces, that we're seeing in the market is a huge proliferation of various kinds of devices, not just smartphones, but, we talk about connected cars, we talk about smart grid, for example, and all kinds of devices being connected to the network. And there's a tremendous amount of innovation happening in this space. So today, if you think about the number of connected devices that we have, it's about 13 to 15 billion devices, that are connected to the network. And when I say the network, I'm talking about, the internet. And by 2020, we estimate, or we are forecasting, that we'll have more than 50 billion devices connected to the network, which almost, translates to 6 devices per person on the planet. And this opens up a huge opportunity in terms of, what's possible from an innovation perspective, from a process transformation perspective, and so on and so forth. Right? Clearly, when you have so many billions of devices connected, you're going to have a proliferation of big data, right? We talk about big data these days, and one of the sources of big data, of course, is the clicks on the web and mobility, billions of SMSs and text messages going across the mobile network and so on. Going forward, the source of big data will essentially be all of these various devices that are now connected, to the network. And we have devices talking to each other and devices communicating with people and so on and so forth. So the Internet of Things, which is something that this was a term, it's an industry term. It was coined in the early days of RFID and being able to track products and goods, etc., packages using RFID tags, active tags, passive tags, and so on and so forth. And that was really about things, right? Connecting things and maybe looking at data, that these things were sort of generating and doing, and integrating that into business processes and so on. The Internet of Everything is more about connecting things in the context of business process transformation and providing not just data but insights and analytics to people, on a real-time basis, and also in enabling other sorts of insights. So the Internet of Everything is much more than just simply things being connected, to the network. I mean, there's very limited, value, that comes by just connecting things. What you want to do is you want to connect things in the context of business processes, in the context of people collaborating and acting upon insights, making decisions, using the data, using the analytics and the insights, and so on and so forth. So one example that we are seeing is in the area of utilities and the smart grid, right? And we all know that utilities are implementing things like smart meters. And previously, if you think back to 4 or 5 years ago, you would have the meter reading person come to your home perhaps once every month and take a manual meter reading. And so what that gave the utility was an idea of what you were consuming based on 12 readings every year. Well, today, smart meters can actually send meter readings once every 15 minutes. And so that translates to almost 35,000 data points that the utility can collect on consumption every year. And basically what's happening is that smart meters enable not just consumption data, but they now allow utilities to interact with consumers in much more interesting ways. They can actually advise you on what you need to do to perhaps lower your energy bills and so on and so forth. And the smart grid, as we all know, is not just about smart meters, but it's about instrumenting the entire grid with intelligence, which leads to big data, and putting analytics on top of that, which can drive efficiencies across the grid. Not just in sort of consumption in homes, but you can pinpoint faults. You can reduce things like mean time to repair, and so on and so forth. So that's just one example of how the Internet of Everything is coming together in the utility space. And there are many other examples, say from healthcare or manufacturing and so on, where, for example, in healthcare, you now have pill bottles that are able to automatically order refills from the pharmacy, or you have pills that you ingest and they send data. They're activated, a sensor is activated by, perhaps, stomach acids and so on, and it's able to send a ping, to a strap or a sensor that you may have on your body, and it tells, it tells your healthcare provider that yes, you've taken your medication on time, and here are your vitals in terms of blood pressure, heart rate, and so on and so forth. So this Internet of Everything is having a tremendous impact on all kinds of industry verticals, healthcare, manufacturing, utilities, and so on and so forth. And data analytics, big data, is at the heart of this market transition. So, in Cisco, we have an economics research group, and we've done a lot of really good bottoms-up research on what's the value at stake from all of this, right? Clearly, the Internet of Everything is, an overarching, what we call market transition that we are all experiencing, that's kind of bringing together mobile, video, big data, cloud, Internet of Things, et cetera, together. And what we did is, just for the private sector alone, looking out 10 years, we estimate a value at stake of almost $14.4 trillion. And this comes from, drivers like improved employee productivity, innovation, improved asset utilization, supply chain and logistics, improved ability to innovate, and so on and so forth. And we estimate that 44% of this value, or almost $6.4 trillion, will be enabled by data analytics itself. And so that is one of the things that's been kind of the motivating factor, the driving factor behind Cisco's strategy, to actually build capabilities in data analytics. So let me talk a little bit about our sort of relevancy in this space and what we are doing. We actually view network data, which is data that traverses networks, as big data, right? One example that I gave was all the billions and trillions of SMSs and text messages that that go over a mobile network. The network really plays two important roles, right? One is it provides context to the data that's being sort of collected. So if you think about Wi-Fi networks, today you can do things like location analytics, and you can provide context such as location of a person, perhaps identity, presence, and so on and so forth. So the network actually provides real-time context to the data, but in addition to that, it can also enable actions to be taken through network control points. So whether it's enforcing network policies, improving quality of service, improving security, and so on and so forth. All of those things can be done through network analytics. And so we see the network really as being central to big data, and particularly as you think about the Internet of Things and the Internet of Everything, this is going to be more and more important. In fact, Cisco spoke a lot about this. For those of you who may have been in Las Vegas last week at the Consumer Electronics Show, the whole theme of the Internet of Everything and data analytics was a pretty important theme that we went through. So if you think about analytics, right? Traditional analytics has been done on what we call data at rest. And this is something that we, especially those of us who grew up in the world of real of relational databases and enterprise data warehouses and SQL. This is very important, and transactional data is still extremely valuable. And what this allowed us to do was, using business intelligence and other tools, we could sort of, really do traditional analytics. We could answer questions like, well, what happened last month? How did sales improve last month? Or if you want to look at profitability by product or by customer segment, we could do all of those things, right? What are the trends, and so on and so forth. And of course, this whole enterprise data warehouses are foundational and very, very critical components of any large company or small company's IT infrastructure and capabilities. But what's happening today is that because of big data and because we talk about the 4 V's, right? Volume, variety, velocity, and value. We want to do analytics not just on data at rest, which is transactional data that exists in our data warehouses, but we also want to analyze what we call data in motion. And data in motion is essentially real-time data that's traversing the network, that may be at the edge of the network, that may be changing rapidly. So whether it's data that you're getting from devices on a shop floor or video cameras, or whether it's consumer sentiment on social media, or whether it's real-time traffic patterns, all of that is what we call data in motion. And when you combine data in motion with data at rest, and when you look at things like structured data and unstructured data, and you look outside the company at publicly available data sets and so on and so forth, that really opens up a tremendous amount of opportunity for companies. We now have the technology and the prowess in the form of software to do all kinds of analytics, right? Predictive analytics, prescriptive analytics, using all of this data, right? And there are so many examples. I mean, from companies like Amazon and Google, and eBay, et cetera, of how Netflix, of how predictive and prescriptive analytics is actually being used to drive value, for the company and for people, right? LinkedIn is yet another example. So what exactly is data in motion, right? So the traditional model is that, look, let's get the data from our transactional systems, let's do some sort of an ETL process, and put it all in our relational database system, our data warehouse, where we have a fixed schema. So we store first and we query later. We do fetch, analyze, report, all the good things that we are all sort of familiar with. And that model is still very important, and it's very foundational, right? It's not going away, right? That's one of the things I want to actually emphasize. That model is not going away. But what's happening is that we now have a new model, which we call data in motion model, where you can actually do some real-time processing of the data even before you do ETL, right? You can actually put in filters. You can do things like aggregations and joins and all kinds of cool stuff on the data as it's streaming in. And you can take action on the basis of what you learn, right? By applying things like machine learning and so on and so forth, you can generate actionable events. And if you like, you can take that raw data stream and you can store that raw data. You've got technologies like Hadoop and MongoDB that allow you to store, raw data as it exists without necessarily forcing it into a schema. So we call this sort of, you basically, in this case, you have a database waiting for queries. In this case, you have a query base waiting for data. So it's a slightly different, paradigm. It's something that's already in place. Many companies are implementing these kind of capabilities, and it's really opening up, a lot of opportunity in terms of insights into the business. And of course, when you think about this whole kind of analytics, value chain, it's all about using this raw data and using that to drive some really informed, business decisions based on insights, that you're able to extract. And I'll be talking a little bit about that, right? There's, one of the things that we are all seeing is that, there is so much advancement of technology in terms of compute power, storage power, and then also software. We have a tremendous amount of software now that's available to do all of this data science and analytics that help us in, making perhaps, better decisions, to drive, business efficiencies and so on. Okay. And from Cisco, from our perspective, I'm, again, I'm part of Cisco Consulting Services, as part of the analytics practice. We are essentially going to market with, three main offers, right? We have an analytics strategy offer where we actually help our customers make sense of the big data and analytics landscape and answer questions like, well, how can analytics really impact your business? Where will it make a difference? And more importantly, how do you embed analytic decision-making capabilities into your operations, right? One of the challenges that all companies face, every company, is that how do they get to consume the output of data analytics, right? How do you take action on the basis of insights? How do you make it part of your mainstream, decision-making and business operations, right? So that's a challenge, that many companies are beginning to address and put in place capabilities, to address that. We also offer something known as Data Science Deep Dive, where we may build an analytics sandbox environment, perhaps, collect some data, structured and unstructured data, develop hypotheses, test those hypotheses, see what insights we come up with, and also, get into how those insights can be useful, for driving the business. And then we have a portfolio of offers which we call Fast Start Analytics, which are very targeted to what we do, within Cisco. And these are the 4 Fast Start Analytics solutions that we have. Collaboration analytics, contact center analytics, business of IT, and location, right? So one of the things we are doing is we are actually embedding analytics as part of our solution portfolio. And at Cisco, we have a very broad collaboration solutions portfolio, which includes video, WebEx, social, so on and so forth. And we now have the tools and capabilities to actually help our enterprises and our customers look at data from the network, right? We've got network collectors and technologies that can actually extract how employees within a company, how they're communicating and collaborating with each other. We can build an enterprise social graph within what's known as organizational network analysis. We can help optimize a video footprint based on network data and so on and so forth. And these collaboration analytics are all geared towards helping a company understand how to improve their collaboration capabilities, how to increase usage and adoption of the right capabilities, and how to drive employee productivity, et cetera, on the basis of that. Contact center analytics is all about collecting data from the interactions that companies have with their customers using contact center, but then going above and beyond that and looking at interactions across multiple channels, not just the contact center, but perhaps social media, IVR systems, the website, and so on and so forth, and integrating all of that data with CRM systems to kind of provide a 360-degree view of the customer in real time, so that when a call comes in, you can do predictive analytics. You can kind of understand what the issue may be that the customer is grappling with, and you can route that call to the best agent based on what you know about the customer, et cetera. Business of IT analytics is essentially about, again, looking at network data and understanding how the company's IT infrastructure is aligned with their overall enterprise architecture and their business strategy. And we get into things like ITIL and other frameworks. Business of IT analytics is all about helping companies understand new IT consumption models, IT risk, energy efficiency in data centers, and so on. And then the last one is location analytics, which is really getting to the heart of the Internet of Things and Internet of Everything. And in fact, I do a lot of work in this area, and this is all about integrating, humans and sensors and machine-to-machine analytics, etc. Whether it's a retail environment or whether it's transportation or a city center or a factory, plant floor, and so on. So what we are doing is we are actually embedding analytics as part of the solution portfolios that we go to market with. So here's an example of immersive video optimization, which is all about the key challenge over there is that, look, companies are rolling or implementing video capabilities to the desktop, to telepresence type of assets, and so on. And if you're a global organization, you may have these video collaboration assets at various parts, in various offices and so on. But the question is that how do you drive scale and efficiencies, and where do you need these assets the most based on what your employees and your knowledge workers need? So immersive video optimization is all about taking that input, to help drive benefits. Same thing with contact center business analytics. I think I may have already covered a lot of this information. And then of course our the location analytics with fast retail, and this is about actually instrumenting store environments with sensors like video cameras and Wi-Fi tags and shelf sensors, RFID weight sensors, etc., to count people entering into the store, exiting the store, to understand where they're going within the store, to understand how long they wait in lines, to look at planograms and shelves, to understand, for example, where are we going out of stock, etc., so that you can improve store operations, you can improve customer satisfaction, and you can improve on-shelf availability. And these are analytics that are done what we call on data in motion at the edge. It's not, what we are not doing over here is we are not, taking raw video data and streaming it back into a cloud, into a data center somewhere, and then running analytics on, on that, and then actually streaming decisions back. No, all of these analytics are actually done at the edge of the network. In fact, in a lot of our video cameras, in all video cameras, we have video analytics capabilities embedded on the software that resides over there. And of course, there is, we've done a lot of sizing of the benefits at stake, the value at stake, and whether it's sales force efficiency, or customer churn reduction, or pricing, etc., or better segmentation, the benefits, the benefits at stake are fairly significant. Okay. So a little bit about what we in Cisco are doing here is, we are actually, we have a very unique approach to capabilities. We build, buy, partner, or invest. And we are doing that across the entire capability stack in big data and analytics. So clearly at the server, storage, networking layer, in infrastructure, we have a lot of our own products, and we partner with companies like EMC, NetApp, etc. On the network-based analytics, we've done a number of really, really cool acquisitions, which have, which are allowing us to embed analytics at the edge of the network into our, endpoints, if you will. So, Cisco Prime Analytics, Carradine, ThinkSmart, which is location analytics, and so on. On the database management side, we have, very important partnerships with companies like Oracle, Microsoft, and others. On the Hadoop and NoSQL, databases, we have, partnerships with companies like Cloudera, MapR, etc. We work with SAP and SAS, and with visualization vendors, not just Splunk, but Tableau and Pentaho and other companies. So, we are building very comprehensive capabilities across the entire stack. Okay. So let me talk a little bit about our approach to to data science, and of course, we'll get into that. This is an area that I'm really passionate about, and the objective of data science is that you want to go from what we call from lab to factory, which is you want to create an environment where you attract top-notch, talent, top-notch data scientists, and you give them the freedom to experiment around, in a laboratory or in a sandbox, type of a setting. But then once you do that, you have to then scale, and that's where, the factory concept, comes into play. And this cartoon is actually very telling. A lot of the data science these days is grounded in very advanced mathematics and algorithms and statistical techniques and so on and so forth. And one of the challenges that we as data scientists face is actually communicating what we are doing, to management and to customers and so on and so forth. So it's no longer sufficient to say that, hey, there's a black box here and something miraculous is happening in the black box. No, I think communication skills are really important for anybody aspiring to be a data scientist. So, here's a quote, that I think I took from, one of the blogs at HBR, and it really says, it really builds upon what I just said, which is that, look, to work with data, you need both a lab and a factory, and the laboratory is an environment where you encourage, intellectual curiosity and experimentation. You allow for some hands-on work to be done on data, and in all of that good stuff that comes along with it. But then you also need the factory, if you have to implement these capabilities at scale and to really drive, some business benefits. Okay. So our approach, to data science, and this is where, so this is what I essentially do, is the key over here is, so data science, sounds very sexy and exciting. The reality is that 90 to 95% of the work that my team does is essentially data preparation. Big data is really good, but as we all know that 90% of the data, the 95% of that data is useless. The question is knowing which 95% is useless and which 5% is useful. And we have a full-time person on our team that is actually who looks at data quality, right, and understands anomalies in the data, is able to clean data. We have a very strong methodology around, managing data quality for any kind of analytics work that we do, looking at inconsistencies and so on and so forth. So data science, the framework for data science is that you begin with understanding what problem you're trying to solve, right? What's the business scenario? What are the use cases? What are the hypotheses that you want to prove using data science and analytics? That's really the first step. The second step is then understanding, well, gee, what data do you need to support those hypotheses, right? And in many cases, the cost of actual data acquisition may be too much, right? That data may not be available. It may not be available in an easy to understand or easy to get manner. So the cost may be too high. So you have to iterate a little bit over here, and you have to understand, well, gee, what can I do with the data that I have or I can easily get, right? And then you spend a lot of time, addressing the quality issues, and preparing those data sets, for further analysis. We also place a lot of emphasis on data visualization because in many cases, a picture, as the saying goes, a picture is worth more than 1,000 words. So in our team, we put a lot of emphasis on using, tools and techniques, whether it's Pentaho or Tableau, et cetera, to visualize data and to understand what story, data is, telling us. So whether it's correlation or histograms or time series analysis, so on and so forth, or looking at clusters, et cetera, we do all of that. And then once we are done with all of that, and we do this in a very cross-functional manner, we then look at, well, gee, what are the insights? What are the unique, points, the anomalies that the data is, telling us? Whether it's through visualization or whether it's through modeling, and that's where some of the more advanced, techniques come into play, machine learning, k-means clustering, shade, other kinds of really cool algorithms, they come into play, and you sort of iterate through all of this. So, I just wanted to talk a little bit about the importance of data visualization. As I said, this is really important because it allows us to present information in a visually easy to understand manner. It assists in answering key questions. that lead to the development of insights. It stimulates in a discussion. If you show trends or patterns or correlation to executives, they get it, they understand, and you can have that brainstorming discussion. You can think about improving business processes. You can think about the kind of insights you want, etc. So just talking a little bit about some of the fast retail hypotheses and questions. It's just an example. Some of the questions that came up some of the work that I've been doing is people want to know, well, how does shopping unit traffic vary by store, by time of day, day of week, month? How long does it take from the time there is a peak in the traffic in the parking lot to a surge of customers at the front end, cashier counters waiting for checkout? Where do customers spend most of their time in the store? How does this vary by time, day, and month? What impact does the weather have on shopping unit traffic, and so on? Can we do any prediction over here, etc., right? So some of the basic visualization we did was, for example, again, these are just example charts. X-axis, we've got time of day. Y-axis, we have number of shopping units. So we are plotting things like what's the mean, what's the standard deviation, how does this vary by time of day. We are looking at relationships between things like average daily temperature and store traffic. Is there a correlation? Is there a causation? And so on and so forth. Okay. So the skills that we put in place are for a well-rounded data science and analytics team is you really want to bring several skill pools of skills together. You definitely need the business and the operations experts who can really help you frame the problem. What problem are you trying to solve? You need data scientists who are well-grounded in techniques, in computing, statistical, algorithms, and also people who are very much hands-on, who are not afraid of rolling up their sleeves and, diving into databases and extracting huge data sets and running queries and all kinds of analytics using R, etc., to see what the data is telling us. You also need engineers and solution architects to actually implement solutions, right? That's where that's where the rubber meets the road, so to speak, in terms of implementation. And then you may need additional experts, statisticians, because statistics it really requires specialized skills. And very often, we fall into the trap of doing the wrong kind of statistical analysis. So in many cases, we have PhD statisticians on our staff who can tell us how to best, construct hypotheses, how to best interpret data, etc. So these are the kind of skills, that we bring together in teams, that are required to work on analytics-based, business projects and engagements. And what's our recruiting strategy? Well, we are actually building capabilities. These are scarce skills. It's not something, these skills are not easily available, but we are targeting, a group of people that we call digital disruptors who seem to be on top of all of these, technology trends and who actually use them. We want people who are quantitative, hands-on, doers, who bring knowledge of statistics, algorithms, machine learning, who know various kinds of databases, PostgreSQL being very foundational to this sort of work, who understand structured, unstructured data, and who know various kinds of data science tools, SQL, SAS, R, programming languages, and so on. And in addition to that, they have to be good team players, good communicators, collaborators. They need to bring a certain amount of intellectual curiosity to the table and a very pragmatic perspective to actually solving business problems. So I hope this was useful. That's all I had from a presentation perspective, and I can take any questions if there are any. Melissa, back to you.
Okay. Well, thank you very much. It really gives us a great perspective, and thanks for sharing about what you're looking in folks to recruit. That was a nice ending to it. There is one question in the box out here. It says, since you mentioned data quality, could you please talk more about how to define which data is useful and in what aspects? So kind of a general question, but if you want to speak to that.
Absolutely. So, um, so that again, it requires, one of the first things we do is, we build a data dictionary, right? Now, a data dictionary is not, it's not just technical, but it's also business, right? So you want to understand what are the various fields of information that are being captured, what's the source of that data, and it's an iterative process, right? You've got your hypotheses, the business scenarios you're trying to test, and you're determining what features, what information you need to test that in those hypotheses. You look at your available data, you understand where it's coming from, you understand the type of that data, is it numeric, is it date, all of that good stuff, and you look for, you have to do things like, when is that data not available, and why is it not available? Is it inconsistent across data sets? So it's kind of very much hands-on, get your hands into the data sort of a process. It's very collaborative because you have the data scientists working with people who are expert in databases, with the business stakeholders, and understanding what the data is telling us and what data needs to be discarded and what data is useful. I mean, in fact, that is a central challenge that we address in the work that we do.
Okay. One of the things that I saw when I started seeing articles come out about a data scientist and thinking about it, of having all those very high levels of education and being a data science, but it's like, how can you actually be a specialist in all different types of businesses? I guess that's what you're explaining about, having a team, and maybe some of the folks on the team can really have the business knowledge and work with those folks. Yeah.
Absolutely, Melissa. Yes, that's exactly right. So look, a data scientist, now these are scarce skills, right? But we are seeing people who kind of graduate, if you have somebody who's graduating with a degree in economics or econometrics or computer science or statistics and math, they have enough of a knowledge to be able to quickly learn new algorithms and, typically most college graduates, these days have some knowledge of a computer programming language, whether it's Python or C or C++, etc., right? So they come with those skills and they come with the quantitative skills, and we can train them on, on other, required skills. I mean, R is a difficult language, but it's something that, people who already know how to program, they can pick up R in a matter of, weeks. Right. So, but these are highly fungible skills. So whether you're working in biostatistics at a university, or whether you're doing weather, pattern analysis for the government, or whether you're doing social, sentiment analysis for a, LinkedIn, or whether you're doing marketing analytics. I mean, these are highly fungible skills, right? And they can be applied across verticals. But that's where the business and the operations experts come into play, right? Because they bring the business context, and that's why you need these complementary skills to all kind of work together.
So what a lot of the folks on this in this presentation that have joined are SQL Server professionals, and what would you suggest to them to increase their skills, or some other things to take on to move towards this direction if they desired?
Well, so the good news is that SQL is extremely important, right? And a lot of the data that's out there. So regardless of the hype and the buzz around unstructured data, a lot of the data that's out there is structured or semi-structured, right? And you can put it in some sort of a, relational or a columnar database. And so the skills around, just the fundamentals of knowing what is, SQL Server, SQL queries, constructing those are absolutely foundational, right? But in terms of developing additional skills, I mean, there's so much material and there's so much information out there that, if you were a little bit rusty on computer programming, well, I would say the first step to do is to pick up, to brush up your skills on, programming, whether that's Python or C or Java, or R. So build some programming skills over there. And then I think, you may want to start, delving a little bit into some of the basic statistical, analysis. And again, there's a lot of material out there. So just understanding some basics around stats and, and visualization of data, all of those things are, I think ways to get started in terms of, if you want to be a data scientist, right?
Right.
To look at, right?
Cool. Another question out there. Did you feel willing to pass your email on to the folks for this session? I don't know if that was on your
Yes,
your
absolutely.
contact screen.
Yes, absolutely. Yeah, I mean, should I just type it here in the text box? Or?
Sure.
Okay, so for some reason, let me just do that. For some reason, it's not allowing me to type in.
Well, I'll reply privately to the person who asked the question, and provide your email address. That's fine.
Fantastic. Yeah.
So I just want to make sure I give a bit more time to folks out there to ask any additional questions. This has been really great to see this from a different perspective, and to also see what a company's actually doing with data science. So I really appreciate your time for putting this together, and this is really awesome stuff. And we will get this recording published out there for you along with the slide deck. So make sure you go to the Business Analytics Virtual Chapter website and go to the archives page, and we'll have it out there. Probably also send out an email to the folks that have joined the virtual chapter out there. So thanks again, and maybe we'll see you at the Business Analytics Conference, Haroon.
Absolutely.
All right.
Absolutely. Thank you so much.
Thank you. Bye.
Okay. Bye.